Hello and welcome to another video. Today we have an MSI B450M PRO VDH on our bench. And first thing I can say is I can see that the BIOS was definitely flashed on this one and that the BIOS chip was removed. So at one point we probably have to take a look at that. But I want to start, because I don't know what is wrong with this board, with our usual checks. So we go to the 24-pin connector first. Let's zoom down on that. We're going to get one probe on ground and the other one bottom left, 3 VSB, 3.3 volts. Looks good, 5 VSB. Fourth pin from the top left has high resistance. Then we go for 12 volts, which is the second pin from the top. Looks also fine. Then the one right to the next, the second one from the top right is 5 volts, also fine. You could also check the PS on, which is I think the fourth one from the bottom right, but that very rarely has problems. And then let's continue with the 12 volts for the CPU power, and that looks good. Then you leave one probe close to the notch, so in this case the upper row, and then you want to probe capacitors or the inductors of the CPU in order to see if the 12 volts is shorted into the CPU phase, and it is not in this case. So then after that, what we can do is we can go for voltage, see for the battery, and we see over 3 volts, that is good. Then we go back into some more resistance measurements, and then you can we take some coils around here. So let's now see, there's a coil right here that has high resistance. Then let's see, there's another coil right there, 200 ohms, okay. Then let's see, do I see any other big coils that we can check? Not really. So I went into this area and I just spotted, I think, physical damage, if I'm not mistaken. If our camera could focus again. Yeah, if it focuses. I see physical damage right here. It's hard to tell on camera, but with the naked eye it's easier to see. Let's go under the microscope and inspect this area where there has been work definitely done, and see what parts we are missing here. So we can see this area has been definitely worked on, but the BIOS chips looks like it's connected fine. Like, it's not the greatest soldering, but it should be fine. That one pin is a little bit dislocated, but yeah. So let's see now. In this area there's very often damage because of the PCIe latch, but in this case it's fine. Let's see further here where VPP should be created. And let's see here now where I think, oh, this wasn't physical damage actually. I thought there was physical damage, but there is not. So I thought that on these pads right here there was physical damage, but there is not. It seems to be fine, interestingly enough. But let's just continue with our search for physical damage when we're already here, because there's many different areas that can have physical damage that we can have a look at. Now at the PWM controller. PWM controller so far looks fine, and around the 12 volt CPU connector also looks fine. Let's go in the area closer to the SAO and see if there's anything here. But all of this looks very fine. So we probably have to look to the BIOS, what could be wrong with that, because it has definitely been flashed. Let's look at the backside if we can see anything. Also looks fine, this area. Behind the CPU socket also looks fine. And also no damage to be seen behind the PCH. So I think we're going to get passive power consumption into here in the CPU and see for what this board actually does then. We are going to use a 2200G now into here. Let's get the DDR voltage tester also in here. Who knows, we might not need it if it doesn't even react to the power button, but we will see. So let's also take a stick of RAM. So we have the power supply in here. Let's also the power button and a speaker onto here. And we have debug LEDs at the right here. So let's have a look at the passive power consumption. And let's see now when this is properly plugged in. About 100 milliamps. Okay, let's see if we have a reaction to the power button. We do. 1.2 amps. And we have CPU LED stuck. Okay, let's see. We have all of the DDR voltages, so they are definitely running. Is the CPU getting warm? The CPU is not getting warm. So, this looks like actually a BIOS issue, to be honest. Because I think we have all of the voltages. Let's check. The most important basically is to check if we have VCore. Yeah, 0.9. We have VCore. So, yeah, the CPU is getting slightly warm. So I would expect this actually to be an issue with the BIOS. Because we basically have all of the voltages, because VCore is already running, and VCore is basically the last thing that runs here. I think we will have a problem with accessing the BIOS or needing to read the BIOS. So let's have a closer look at that. I want to show you what I always do to program especially MSI BIOSes, because they have a very good header close to it that we can use. So let's switch over to the microscope once more in order to be able to show you that. So what we need to do is we need to bend back this one pin. So let's just with tweezers get it a little bit. Really need to be careful to not overdo it here, because going in one direction can easily bend it into the other direction that we don't want it to be. So that might be fine now. That might be good enough. The BIOS chip itself, the area looks awful. Let's resolder a little bit of the area so that it will be looking better, and we make sure that all of the connections are proper, and then we also clean up a little bit. So what I like to do is just flux the area up. Then we take our soldering iron and we go over all of these joints, making sure that all of these joints are properly connected now. And there it is. And now what we want to do, we want to clean this area up. Let's have a good go at it with the IPA and the cleaning pad. Because I don't think it was an actual issue with the contact of the BIOS chip, to be honest. But I just want to make sure. And we might need to also desolder this BIOS chip. We will have to see if we can access it through this SPI header that we have right here. And I want to show you how I do that after I have cleaned it up a little bit more here. So if you cannot clean up, like if you see this discoloration like that, you can see there all the orange and stuff like that. If that doesn't clean up, you might need to heat it up first with like hot air in order to be able to remove it. In this case, it already looks a lot better than it did before, but it still doesn't remove properly at the other places where no flux was. But that shouldn't concern us. Let me get my tools in order to flash this BIOS, and I want to show you what I do. So we're going to be using this JTAG connector that I've made. You can see I've marked a pin right there with pin 1, and you have the marking of pin 1 right there. And what I did is I took my multimeter, or used the board view, and traced out this connector where it connects to these pins. So all of what this connector that I'm plugging in right here does is to adapt these pins to that SPI chip. Without needing to desolder it, we can flash to it, because this cable just leads to my programmer. Let me show you that in the overview. There's the SPI header, and this just connects via a cable into here, into my programmer. You can also use the other CH programmer, the cheap one, and do the exact same thing. But make sure that you use the 1.8 volt adapter. This BIOS programmer doesn't need an adapter. It can automatically detect the voltage that it needs, and we can program it with that. So let's go over to the PC and flash this BIOS onto here. So what we do is we just going to search for the mainboard that we have, B450 Pro VDH. I know you can partially not see that, but you just click the link from MSI, and then you go into support. Then we go into BIOSes, and then we're going to be using one of the first BIOSes. I often don't like to use beta versions just to be sure, and use one of the latest stable ones, like for example we're going to get this one now. So this is now the files that we get, and now let's go into our BIOS programmer. So let's see if it recognizes the chip. It does not currently. Okay, let me try to reconnect some stuff. So I cannot get a connection to the chip via my leads, and I'm pretty sure that my method of connecting is correct. It might be that the chip is oriented the wrong way, that the chip is maybe faulty, or that there's some missing passive components like a resistor around the chip. So we will have to take off the chip now. Let's do that and put it onto an adapter board. So we are going to be using this adapter right here. This has 8 pins for breakout like that. These pins right here. And it has different footprints for different kind of BIOS chips. And we're going to be putting it onto here. So let's desolder that BIOS chip and then make sure that it works properly. So let's flux this up. We could be protecting this connector right here. Let's do that at least a little bit. Get some Kapton tape. But I don't think it will do much. It also won't hurt the connector a lot, because we're going to be quick with the hot air. Let's take our hot air. The area is also prepared where the BIOS chip is going to go afterwards. So in this case 475 degrees. And we're just going to be blasting this chip off of here now. And with the leaded solder it removed quite fast. And now I'm just going to be putting it onto my adapter here. Now let's clean the area up of the board while we can, because now the area is definitely hot enough where the other flux that was on there is hot enough in order to be able to be removed. So let's see, do we have a triangle somewhere here that indicates our pin 1? Because one of the last times I was very blind and thought there was nothing indicating pin 1, and I got very much and very often corrected in the comment section that there was an indication for pin 1. But I'm pretty sure there is none this time. Like there's no arrow or somewhere showing to one of the edge pins that it would be pin 1. Because like that I also can't verify if the BIOS chip was on the correct way here or not. So if you can see anything that indicates pin 1, let me know, because I currently cannot. But let's go further then to the PC and let's see if the BIOS chip now reacts to the BIOS programmer while it's on that adapter plate. Let me show you the adapter plate right here. Here it's now connected, pin 1 in the top left, as you can see by the dot. And yeah, let's see now then. So once more in our BIOS programming software, let's have a look now if the chip gets identified. Yes, it does get identified. Okay, and I think my program just crashed. So after now some hiccups with my program, it now recognizes the chip normally. Let's read out its content. And what we're going to do, we're going to be saving the file that is on here. And we're going to be replacing it with a known good one, just to be sure, even though the file could be good that it's on here. But just to be sure, I want to put my own file into there and make sure that it works properly. So we have the content read, and I gotta say it looks fine. This looks like a usual BIOS from MSI, but we're going to be flashing the one that I downloaded now. This is a 7A38 version 4.0, and we're going to be using this file. I've been asked many times that this extension is not the usual extension that you use, but you can just flash this file. But before flashing that, we are going to save that file into the B450, also into the same folder, just to be sure that the original bin is there. And now you can see they both have the exact same size. This is very important. So this is the one that we pulled off the chip, and this is the one that we're going to put onto here. So we're going to open it up, and you can see it's very similar. So let's program this now. It's going to be starting to erase the chip first, and then it's going to be programming everything onto there. And what I want to do while it's doing that, I want to check for the orientation of that BIOS chip. So the orientation seems to be fine, because there's pin 1 in the bottom right, and that is also where the chip was, so that orientation was right. So now we will just have to wait for the BIOS to be programmed. And now the programming is in progress. So now the BIOS chip is programmed. Let's now get it back onto the board and see if that has had any change for us now. So what we can do now, in order to preserve this board a little bit more and not char too much, we can put some flux onto here, and we can wick off these pads clean. So we will use some solder braid and just clean off the pads that are here. Take off the old solder that is on here. So now they are cleaned. And what we can do now, instead of using hot air, we need hot air to take the chip off of the adapter that I have. But we can now just place the chip in the right orientation, which is the other one, onto here. And now it can just sit flat where it should be, because we cleaned off the pads. And we can now just take some solder and just solder it on with the iron instead of using hot air. So get heat into the pad, into the pin, and that's already the chip on now. And now you can just go ahead and solder on every single pad here. And now the chip is on without using any hot air and not destroying a connector or anything, and using minimal heat. And now we have a good connection. Now we're just going to be cleaning up the area again using our sponges. And with that, we prevented using hot air in order to put this BIOS chip perfectly back on. And you can see we have good solder joints, and this time it's now in the, also like before, it was in the correct orientation. We checked that with the board view. And let's hope now that that will have solved our problem, and that it now reads this BIOS. So the area is clean. Let's now go into the overview and hope that now our CPU gets recognized and that we can start this board up now. So let's build it up once more. Processor, RAM, power. And let's see now if we now have a different reaction instead of just CPU LED, and if we have more than 1.2 amps of power consumption with the new BIOS chip in place now. So let's see. 1.2 amps still. That is not good. So the BIOS chip was not the problem with the BIOS in it. So I would expect that there's actually some missing signal somewhere because of a knocked off component or something like that. Because I think the BIOS is not being accessed, or something in the chain might be broken, that it is not going further. I will have to take a better look in order to see if there's anything ripped off anywhere, because the voltages seem to be all there that need to be there, because as I said, we have V-core, and that is like the biggest indication. But let me now go under the microscope then and have a good look again at this board if I can see anything. So I just took off the heatsink for the PCH and I saw something that is very bad. You can see there's a ginormous pad on here, a thermal pad, that they have used as a replacement to this thermal paste, and this is really bad. If you know, in GPUs, having too thick pads causes the solder balls to crack, if you put on the heatsink. And that might be what happened in our case as well. I cannot confirm that yet. I'm still searching for knocked off components. There still might be damage around there, but this could be our culprit why our PCH died or has maybe bad contact on here. So I will be continuing the search for knocked off components. Maybe I can find something. So after quite some time, I found something actually on this board. Let me show you. When we turn this board on, we see the same power consumption as before, 1.4 amps. If we now take the ground and look at this inductor right here, we see no voltage. So let me zoom down on that a little bit more. We have two regulators. There's one small regulator right here that does have 105 volts, but this regulator right here is not running. There's no voltage on here. And that regulator is also 1.05 volts. That should be starting as soon as the board gets 12 volts and the PS on is actually there. And we have quite low resistance on here, 12.7, but it should be fine, I think, for the PCH. But we need to find out why this voltage isn't running. So let's go under the microscope then and have a look in this area. So this is our regulator in question, and I've been poking around here a little bit already. I think so we know we probably let's analyze the circuit a little bit. We can see that this is probably the input of it. This pin right there, you can see it goes to a big track right there. Then there's probably the output is probably somewhere on this side. Yeah, these two are probably the output that go to the inductor here. And then there's all of the enabled stuff and similar stuff like that. So for this regulator, let's see if we have 12 volts right there. There's an inductor right here where I think there should be 12 volts and there should be 12 volts. Let's check if that inductor has 0 ohms. Yeah, that inductor has low resistance. That is very good to see. Let's now get the board turned on once more. And let's see if we have 12 volts at that point. So board is on. Let's see now. We need 12 volts here. Yeah, we have 12 volts. Just have my probes reversed. That's why I was reading minus 12. But now we have 12 volts there. And if we read right here, this should be the output. At the bottom, we have nothing. Okay. Let's see then, at this point, do we have anything? We have nothing here. And at this point after this resistor, we also have nothing. And this point of that resistor, also nothing. So there's basically very little things around this thing actually running. Yeah. We basically have no voltage anywhere, except that 12 volts that we saw as the supply input. But everything else seems to be low. Yeah. There is a little bit of voltage. But yeah, we will have to find out why this isn't running. Probably because the enable signal is missing, but the supply voltage is there. So let's go into the schematic of this board and have a look at how this controller works. So now we are in our schematic, and you can see for promontory 105 volt S0. So in the S0 state, it's the 105 volts, and this is the name for the PCHs on AMD. And you can see the 105 volts in S0 state is 5.5 amps. That's why there's a bigger regulator. And in the NS5 state, that's the small regulator that we saw, is 0.05 amps. That is written right there. So right here at the bottom, we see the actual regulator for the S5 state. That is the small one. That is just the 5-pin device that we have that gives out the very low voltage, the very low amperage that we need. But what we want to look at is this one, U38. And let's see now. We have V in. That is what we saw. That is through L22 that we saw. That is the 12 volts coming in. Then we have VCC. Okay, this is just pulled to ground. Then LP is not connected. There's an enable signal right here. And that enable signal is fed through VIN. Question is, where does this VIN come from? And we also have enabling an enabling MOSFET right here. Let's see, can I zoom down that you can see it better? So for this we had this exact thing multiple times. All what we need is the sleep state right here. If this sleep state here is present, then our 5 VSB is being pulled low to ground through this transistor right here. And with this transistor pulling 5 VSB low to ground, this gate isn't being enabled anymore, and D2 and S2 isn't connected anymore. And then this VIN connects into the enable signal, and that is important that we have that. And the other sides that we have is what is important is the bootstrapping, that this capacitor and this resistor is fine, or else the regulator won't work. Then we have the switching output. This is just something connected to ground, okay. Feedback, yeah. All of this isn't really important. Most important is the enable signal. And let's find out where this is coming from. Because this might be connected. Oh yeah, this is just connected to the 12 volts also, huh? Because this is the exact same signal. Yeah, and this is only D2. So this signal right here is also just connected through this resistor 390k to the enable signal. So we will have to check if 12 volts is on this side of the resistor, on the other side of the resistor, if this is being enabled or not, this dual MOSFET here. And yeah, and check if this resistor is still 390k, so that we get enable signal onto this controller. So let's then check that. So let's now have a look. It's this resistor right there, which is our enable signal, or where our enable signal goes. 0 ohms. Why is that 0 ohms? No way that's 0 ohms. What? This thing is supposed to be like 390k or something like that. There's no power on here. Why does it read so much? Let's try that again. So this is my probes touching, yeah. Let's see once more. Let's go from here to there. Why does it read so low resistance? Yeah, it reads an ohm. How is that? Yeah, going into the lower ranges. It's just an ohm. But it doesn't read an ohm anymore as soon as I go into my lowest range. But something here is weird. But yeah, you can see now. Or is that kilo ohms? Yeah, it reads kilo ohms, but why is that? 1.3 kilo ohms. Like, this should be 390. Okay, let's unsolder that resistor, because this is very suspicious. That is something very weird. Let's let it solder on both of these sides of the resistor. And we will probably be using hot air to put it to the side and then check it. Okay. Quite lucky I got the resistor out of the way just like that. Let's see now. I will go onto the resistor. Let's check its resistance. And it's still low. That is very weird. How's that resistor showing such a low resistance? This resistor basically shows short circuit. Let's get it into a different position. just to be sure. So, I've moved it to the side a little bit, just to be sure. Let's check it now. Going from this side to there. Okay, now I'm not getting that low resistance anymore. Let's check from here to here. Yeah, now I get 390k. So the resistor is fine. But why is this line shorted? What? Okay, I'm getting very weird readings right now. Okay, now I don't get a connection between these two anymore. Let's clean up the place a little bit that we can see better. And then check once more. So now it's cleaned up. Let's see once more. If we check from this point to this point now, we get still the kilo ohms of resistance. Okay, interesting. Because I feel like there shouldn't be, it shouldn't be like that. I feel like there should only be the 390k from that resistor. The only problem then might be the controller itself. But let's check without this in place. Let's check what this transistor is here doing. This is the transistor that takes 5 VSB from this side onto here. And then this would enable to connect that and that to ground, because that is our enable signal and this is ground. So if this has voltage, these two are connected and go to there. If this has voltage, this one, this middle pin, this is the gate, these two get connected. And if we have voltage there, if we have the S3 state there, then this and this gets connected to ground. So that means that the 5 VSB then gets connected to ground and is not enabling the gate anymore. So let's check that. So let's see here then. We should have 5 VSB right there. We have that. Then on this side we want to see nothing. Yeah, we have nothing here. And let's check. Then the S3 signal should be present on the middle pin right here. Right there. Yeah. So this circuit works like it should be, but we still do not have that enable signal, which is very weird. So let's put that resistor back in and then check once more. So we know that the one side of the enable circuit does work as intended with the S3, but something about this resistor not having 12 watts on the other side is weird then. Flux it up once more, and I will not be using hot air, I will just be using the soldering iron in this case to put on the resistor back into its place. So the resistor is back in place, and if we have a look now, we still don't have 12 volts right here. Yeah, still nothing. But we do have the 12 volts on this side. So is the other side shorted to ground while it's running? Because it shouldn't be. Yeah, we don't have a short to ground, so it's not being pulled low by anything. So I'm very curious if this controller might be dead. Because I'm missing some information here, or like I'm not really sure where to go from here, because we do have the VN and the enable is basically there, but it's being pulled low by something. And so I would want to replace this controller just to be sure and put another one on, and yeah, and see if that helps the situation. So let me source a donor board. I think I have one where I can take that controller from. So I've removed the controller now. You probably saw me take the donor controller as well. With the controller out, I want to check if our enable signal is now present or not. If that controller was maybe dragging it down. So turning the board on. Let's see now if now we have the enable signal here. And now we have voltage here, 2.5 volts. So that controller seems to have been dragging the enable signal down. So let's then put the donor controller into there. I made sure to have none of the non-leaded solder there anymore. So we're now going to put leaded solder on all of these pads, so that the melting point is way lower and we will have it easier to put this controller onto here. So good fluffy pads all around. Let's clean up the old Flux once more, and then I'm going to be putting in the donor controller onto here. So old Flux is cleaned off. Let's put some new Flux onto here. So good amount of Flux. And now I'll be taking the donor controller. Let's see now. It needs to be sitting like this, because we see some reflections on the chip. Let's do it like that. I have a polarizing filter on my microscope now, and now I can, when we have very refractive situations, I can just turn that polarizer and then see it very well, even with all of the flux here. You can see this is without it basically, and this is with the polarization filter. Let's get the hot air into here and put this chip on. Yep, that should be it. That should be the controller on here. And let's clean up the area once more. And then have a look if our enable signal is gone again, or if we still have our enable signal. So with the area basically cleaned up, let's now go into the overview then that we have. Because it could very well be that the board now turns on, and I want to show you that in the overview. So let's switch over. So if we now see more than 1.4 amps of power consumption, pretty surely this board will be fixed. So let's hit it. Yeah, 2.6, there we go. That is very good to see. And now we have changing postcodes. You store just 7 amps there. CPU, DRAM. We're going to see almost 10 amps probably. Yeah, there are 8 amps right there, you can see. And it's trying to start again. Restarting by its own. 8 amps. We should... And there's an indication for missing VGA. That is very good to see. So we need, there isn't an APU in here currently. There's a 1600X in here. Let's get an APU in here. So we can just use the internal VGA out of it. So a 2200G in here. Let's get the cooler onto here and also get a display connected. So let's bring the post screen into here and let's try this again. Different CPU. Probably going to be RAM training it, all of that again. 2.5 amps, 3 amps, 5 amps. Restarting 2.5 amps. 3 amps, 5 amps, 3 amps. VGA LED and post screen. Very great to see. We have keyboard indication also, and we can go now. Continue from here. Yeah, and there's our BIOS. That is very great to see. So yeah, I thought the PCH might be dead here. After I saw what I have done with this thermal pad right here, which is way too thick on this cooler, I thought that the PCH would be dead here. But I will be taking off this old thermal, this whatever pad or paste or whatever this is, and I will be applying some new thermal paste onto here so that the PCH gets cooled again. And yeah, all we had was a dead buck converter, an NB671 I think it was, or something like that. Yeah, I've seen that before, that when the enable signal gets pulled low somehow, that the controller is at fault, pulling that signal low. And this is why I went to changing out the controller here, because I've seen that before. And we checked all of the other things. We checked that double AND gate that was that double AND MOSFET next to it, and that was right. Everything there checked out with the S3 signal and pulling down the 5 VSB. And we also checked that resistor. That the resistor had the right resistance on it. And as soon as I took off the controller and then saw the 2.5 volts as the enable signal, I was pretty sure that the controller was going to be the bad one on here. And yeah, it came true that now the board works again. We had a dead controller, we had a missing voltage for the PCH. And important here to know is we have different states of motherboard. We have S5, S0, there's also S3 state, and S5 is the state where you have when you are in standby. You saw there's a different 105 volts for the standby mode, which is the small regulator, and then we have in S0 we have another state where we use this buck converter for the 105 volts, that there can actually be a lot of amperage being drawn. So going through the power sequence or going through the necessary voltages for this board helped us to find the missing voltage here. And yeah, now the board is fixed. I hope you learned something. I hope you enjoyed the video. As always, all of my tools are linked in the video description. This was Mainboard Medic. Thank you very much and goodbye.